this was a short one. I would say so this is the spring stretching work problem. I would say the most common problem here was that people didn't ask themselves the question, or they didn't give themselves the right answer to the question, is this a calculus work problem or a non-calculus work problem? We had talked before about how work is force times distance as long as the force is constant. So if you are lifting something to overcome the force of gravity is constant, and so you don't need any integrals or any calculus to calculate the work involved. It's just the force required to lift it times the distance. So the question is the force in this problem constant? Here we've got a spring, and as you know, the force required to lift a spring is not constant, it's proportional to the displacement. So the correct format for this is the work is going to be the force required to move the spring integrated from the starting length to the ending length. So it's force integrated across distance. And I would say virtually everybody who missed this problem, that's the portion they missed. They didn't get that part. But let's go ahead and solve it anyway. So it takes 5 pounds of force to hold a spring 1/6 of a foot past its natural resting length. I'm going to do this problem all in terms of inches. So 1/6 of a foot is 2 inches. Note this is foot in inches, not derivatives. All right, so I know that it takes 5 pounds of force to hold it at 2 inches. So that gives me that K equals -5/2. So that gives me that my new force equation is, let's see, if K is -5/2, then that gives me force equals 5/2 times X, where X is my displacement. I just replaced X with D. D with X. Okay. So now the question is, how much work will be required to stretch it from its resting state to 1 foot past its resting state? So its resting state is a distance of 0. 1 foot past its resting state is 12 inches. So work is the integral from 0 to 12 of 5/2 x dx. So let's go ahead and do that integral. So that's 5x squared. 5/4 x squared. Yep. Evaluated from 0 to 12. So that's, I'll have 5/4 on the outside. So that's 12 squared minus 0 squared. So that's 144 times 5 divided by 4. Equals 180 foot-pounds of work. And that's it.